Okay, so this is the final question of the 2017 paper, and it's a geometry question. Okay, so the first part of the question, part I, is proving that triangle ACE is isosceles. So let's have a look at ACE. I'm just going to draw it out just so we can see it a bit clearer. So ACE is this final triangle here. We need to prove that it is an isosceles triangle, so two of the sides are the same, or two angles are the same. So I'm probably going to try and prove that two of the sides are the same because we've been given facts about midpoints, distances, and we've also been given this identity here. So I think it's most likely that we're going to be proving that two of the sides are the same. Okay. So straight away I know that I'm looking somehow to prove that AC is equal to something else because I know that AC is in this identity here. So, probably AE if I was a betting man, but anyway, we'll work it out in a second. All right, so how can we start talking about one of these other sides? Well, we know that if M is the midpoint of BC, D should also be the midpoint of BE. So let's just write that. So if BM equals MC, which is given, BD must also equal DE. And I think the reason you give is because parallel lines intersect crossing lines in equal ratios, if that kind of makes sense. So basically, if I put any other line through these two parallel lines, so you can sort of think of there also being another parallel line here, like through that point there. So what I'm saying is that if I put any line through those three parallel lines, the ratio of sides will still be the same. Anyway, all right, so I know that. So I know that DE has to equal BD, and I know that I've got BD in this equation here. So what can we do? All right, well, let's look at DE here, okay? So DE is equal to DA plus AE, and all of that is equal to this side here. So I can say that BD is equal to DE, like we said, and DE is just DA plus AE, okay? And the reason that I was looking for this is because that looks a lot like this identity here. We've got a BD is equal to DA plus AC. So what I'm going to say is, I'm going to write that out, BD is equal to DA plus AC, and that was given. So therefore we can equate those two equations. We get DA plus AC, or AE, sorry, is equal to DA plus AC, and therefore these will just cancel, and we get the fact that AE is equal to AC. Okay, and that's all we need to do, because then we can say that triangle ACE is isosceles because, and the reason, remember that's important for these questions, that there are two sets or two equal sides. Okay, all right, let's move on to the next question. So the next question is saying, let's write it on this side actually, so we can do it. The next question is saying that point F is chosen on BC so that AF is parallel to DM. So what we then need to show is that AF bisects BAC. So if that's the case, we can say that those two angles are equal, right? So that's what we're trying to show here. Okay. So what we know, where we would start, I'm pretty sure, because we're thinking about angles, is that, DM is parallel to FA, which is parallel to CE. So that's given to us. Okay. So now what I'm going to do is I'm going to basically follow the angle around the drawing and see if I can get it to land here. Okay, so I'm actually going to rub that out. That's going to be my goal. And in blue, I'm going to show where I'm going to follow the angle to. That kind of makes sense. That's something how I sometimes think about it. So I know that this angle here also can be up there. And the reason for that is that corresponding angles on parallel lines are equal, okay? And then I know that AEC, what we worked out back up here is that actually these two lines are the same length, and this is an isosceles triangle, yeah? That's what we proved in part I. So that means down here also has to be theta. And then again, on parallel lines, I know that that there has to be alpha because on alternate angles on parallel lines are equal, okay? And there you have it, that's it. So then you know that these two angles are equal, and therefore FA bisects the larger angle BAC, okay? So let's write that out, because that's important in these sort of questions, is how you set it out. So let's start off by saying that angle BAF is equal to angle BEC, okay? And the reason for that is corresponding angles on parallel lines are equal. Apologies for the handwriting. And then the next one I'm going to do is I'm going to say that angle BEC is equal to angle ACE. And the reason for that is that triangle AEC is isosceles. Isosceles. Can't really spell very well. AIC is isosceles, and we can say shown in I, just for good measure. And then the next leap, I went from down here to up there. And the way I did that was I said that ACE is equal to angle FAC because alternate angles on parallel lines are equal. Okay, and then the clincher is that therefore BAF is equal to angle FAC, therefore FA bisects angle BAC. And that is the final question of the 2017 past paper.
Snack is an online platform to instantly create and share videos just like this one. To watch more or try a hand at making your own, head over to snackapp.io.